Let's compute, visualize the patterns, find the truth. Big data swinging, it's got...
Welcome back to our model validation specialization. In this video, we'll set up the development environment for our hands-on model validation exercises. Having a consistent, reproducible environment isn't just about convenience. It's a critical professional practice, especially in validation work. The same model might perform differently across environments due to package versions or random seed handling. Our goal today is to create an environment that's not only appropriate for this course, but also reflects real-world best practices used by data science teams. Before we dive into setup, let's understand why proper environment management is essential for validation work. First, reproducibility is critical. We need consistent results when validating models, especially when comparing different approaches. Second, dependency conflicts are real. Different projects often require different versions of the same libraries. Without isolated environments, you'll eventually hit conflicts. Third, production deployment requires identical development and production environments to ensure validated models perform the same way in both. Fourth, collaboration becomes much easier when everyone uses the same environment specification. These aren't just theoretical concerns. I've seen models pass validation in development, but fail in production due to environment differences. Proper environment management is a professional skill worth mastering. To make setup easy, we've created an automated script in the course's GitHub repository. Let's walk through using it. First, clone the repository if you haven't already, then run the setup script. This script installs all the libraries we need, such as Python 3.9 or higher, Jupyter Notebook and Jupyter Lab, Pandas, NumPy, scikit-learn, matplotlib, Seaborn, and some additional validation-specific packages. The script also verifies that everything is installed correctly by running a quick test. If you see all green checks, congratulations, you're ready to go. While the setup script works for simple installations, professional data scientists almost always use isolated environments. Let me show you the two main approaches. Conda, which is recommended for beginners. Conda creates a separate Python installation for each environment, providing the strongest isolation. This is particularly useful for packages with binary dependencies like TensorFlow or PyTorch. Virtual environments. Virtual environments are lighter weight but only isolate Python packages, not system libraries. In professional settings, I strongly recommend using environment isolation for every project. It saved me countless hours of debugging dependency conflicts and helped ensure models perform consistently across environments. For more advanced users, there are several professional-grade tools for environment management. Docker containers provide complete isolation, including the operating system, and are the gold standard for production deployment. Poetry and PyPenV offer modern dependency management with log files to ensure exact version matching. CondaForge provides additional packages beyond the standard Conda repositories. Environment.yml files for Conda and PyProject.toml for Poetry define environments in a shareable, version-controlled way. You don't need these advanced tools for our course, but they're worth knowing about for professional work. Even for this course, I highly recommend at least using a virtual environment or Conda environment rather than installing packages globally. We also provide Google Colab notebooks for all our exercises, which can be helpful if you're having installation issues. However, I want to emphasize why local development environments are the professional standard: data privacy and security. Local environments keep sensitive data on your systems. Many companies prohibit uploading proprietary data to third-party cloud services. Resource consistency. Cloud notebook resources can vary or time out, causing validation results to change or processes to terminate mid-run. Production integration. Local environments can mirror production setups more closely, creating a smoother path to deployment. Large datasets. Cloud notebooks often struggle with industrial-scale datasets, while local setups can connect directly to data warehouses or local storage. Workflow integration. Local environments integrate better with version control, testing frameworks, and MLOps tools. While Colab is convenient for learning, I've rarely seen it used in production environments. Professional data scientists typically work in local environments or dedicated cloud compute specifically configured for their company's needs. Before we wrap up, let's verify that everything is working correctly by running the verification notebook. This notebook checks your setup and runs some basic validation code to ensure everything works properly. If you encounter issues, here are some common troubleshooting steps. For package conflicts, try creating a fresh environment. For Jupyter kernel issues, verify the kernel is using your environment's Python. For permission errors, try running as administrator or using sudo carefully. Check our GitHub repository's issues section for known problems and solutions. We also have a dedicated discussion thread for setup issues where our team provides support at soyouthinkyoukandata.com. Taking the time to set up a proper environment now will save you hours of frustration later. While it might seem tempting to jump straight to Colab, the professional skills you develop by managing your own environment will serve you throughout your data science career. In the next video, we'll explore the Google Flu Trends case study, which perfectly illustrates why proper validation is so critical in real-world applications. See you there.